Hello students, welcome to the IMS Gate Academy. Myself Ravi Bogdula. As part of the Gate Score Booster series, so in this session I would like to take the second part of computer networks. The computer networks, we have done one session in which almost 50 to 60% of the syllabus we have covered with taking the more important questions, and we have also observed some time. So now we will continue the remaining portion of the computer networks. Again, I have taken almost 20 to 25 questions which are important, through which we can revise the what concepts. Hi JP, good evening. How are you, ma? I am good. I hope your preparation is going well. And also, my dear students, try to join the session as early as possible, and also share the link to among your friends so that they can also get benefited from the session. And those who are able to attend live session, you can attend. Otherwise, later also you can watch it, because we have done the in this part of the series, we have done on operating system, computer organization architecture, even DBMS, now computer networks, even other subjects also will take it. So I hope everything is clear so that we can continue the session. Everyone? Good evening, Matan. Good evening, Matan. Okay. So we'll move on to the part 2, computer networks part 2. Okay. In which I would like to discuss the things, from switching, it is part of the network layer. So we'll observe like majorly, many year papers, if you see a couple of times they framed on packet switching. Even there was a question in 2024 GATE also. So from packet switching they framed it. So IP part is very important. It is part of again network layer. So some portion of the IP we have done, like IP addressing system, in which subnetting part and supernetting, those related questions we have seen it, correct. So now here just we'll looking into what IP header part as well as the fragmentation, role of fragmentation, we'll observe it. Some network layer protocols, even some DHCP, you see all the layers can be seen. Now it is part of network layer only, correct, it's part of network layer only. It has even more transport layer also, right. RAP, address resolution protocol, reverse of ARP, reverse of ARP, bootp, DHCP and ICMP package. So related to this, so we can expect the theoretical questions only. Most of the time I have seen, theoretical aspect like MSQ questions, MCQ questions can be observed here. Coming into the most important topic from the computer networks, TCP and UDP. The both protocols part of the transport layer only, correct? Both part of the transport layer. Both are part of the transport layer. So which are very much important. So in which majorly try to focus on wraparound time calculation, the role of wraparound time, and followed by TCP process state transition diagram, congestion control and error control need to be focused. Application layer, as per the syllabus, these are the protocols are mentioned, so need to be focused. Finally you can learn the network address translation. It is also part of the network, but separately just we are discussing. Okay. So come to the point, these are the things we are going to be focused. Okay. From switching, understand. The switching is broadly classified into two types, correct or not? One is circuit switching. One is circuit switching. Second one is what? Packet switching, correct? The third one is what? Message switching. Right. Basically this used in telephone network. It is not part of the computer networks. This is part of the computer networks. This again further can be seen The first one is a virtual circuit switching. The second one is a datagram switching. Okay. So this is the part to understand, very important. This is used in computer networks. Okay, correct or not? So this is virtual circuit switching or virtual packet switching also can say. Virtual circuit or packet switching also can say. Virtual packet switching also can tell now. Am I right, all of you? So these are the major things need to be studied. Okay. So related to this one, some questions we'll see, then later we'll observe it. Okay. So which of the following statement is or true related to this switching only? Can you please answer what are the statements are right? What are the statements are right? Yes, all of you, those who are watching, just tell me the answer, like what are the statements are right. And also I am strongly recommending all of you, try to share the link among your friends so that they can also join. Yes, ma'am, what are the statements are right? So three broad categories of networks are circuit switching is given, packet switching and message switching. So just now we understand, correct or not? So circuit switch network resource need not be reserved during the setup phase or connection establishment phase. In packet switching there is no resource allocation for a packet code. All IP over voice uses the datagram services. All IP over voice uses the datagram services. Yes, yes. So tell me what are the statements are right? Yes, soil mechanics. So we have considered the importance of the student. That is the reason we have started a series. So the GATE score booster session. Definitely, utilize this session, all the subjects, even other branches also. Try to utilize. Go through the sessions, because through these sessions you can revise, you can understand the concept even better way. And these are the topic which you are choosing most expected areas. So upcoming GATE or any GATE examination. Sir, 1, 3, 4, 3, 4 are true, 3, 4. So 1 is false. So who is telling? The Hamad, you are saying the statement 1 is false. Statement 1 is false. Other is telling the 3 and 4 only. Yeah. Once again try, once again check. Hamad, JP, are you sure? 3 statements are correct, 1, 3, 4. Very good, ma, very good. This is statement 1 is true, correct or not? Just now we understand. So switching categories are 3 types, correct or not? Circuit switching, packet switching and message switching, true. Circuit switching network resources are reserved actually. It is saying that not reserved, it is reserved. Circuit switching, directly connection, physical connectivity is there. Physical connection will be there. So telephonic network, correct or not? Telephonic network having the physical connection, not modern telephonic. So before we used to have the complete physical wire connected between the source and the destination, correct or not? So this is incorrect statement. In packet switching there is no resource allocation for the packet code. So packet switching there is no resource allocation. So now please understand, resource allocation will be there for what? Virtual circuit switching. But there is also datagram service switching, it is part of the what? Packet switching only, correct or not? So they were not telling exactly which part. So as per this if you take, yes, this takes. So in this case datagram services, datagram switching, resource reservation not at all required. So resource reservation not at all required. Directly you can transmit, directly you can transmit. So data. So only a router will forward. If the router has enough buffer, it will forward. Otherwise it can be dropped also, correct or not? It can be dropped. So therefore I can say this is a statement true. Then all IP over voice services uses the datagram service only. You understand now? today WhatsApp, you can take no, Skype calls, all video calls, understand, Google Meets and WhatsApp video and audio calls, all are, they are not using telephonic spectrum to transmit the data, they are using internet protocol. So they create IP datagrams to transmit the data. So when this data packets, when you are sending to IP, so like internet protocol, and it is, we know, right, datagram services are what? Unreliable. Any times the packet can be dropped. Yes, anytime packet can be dropped, correct or not? So this all are using datagram service only. That is the reason, no, when you are talking a call through WhatsApp voice or video, sometime directly disconnected, correct or not? Again you have to connect it, right? Again you connect it. It is completely unreliable protocol, but very cheaper, right? Yes or no? Sending voice and video message over the internet protocol is very cost effective, very cheaper compared to what on telephonic spectrum. Suppose you take the STD calls or like international calls, especially telephonic spectrum, if it is very costly, it will consume like separate reservation, like you have to reserve a lot of resources, that is expensive, correct or not? That is the reason, understand, sending IP, like understand, okay, voice message IP protocol is very good. So we can minimize the cost. This statement you try to rewrite, all IP over voice over IPs you should write it, like all voice calls are sending an IP protocol only. We called voice over IP, we called. This is just change the statement. All voice over sending out IP protocol uses our datagram services, uses the datagram services. The statement is true. So therefore, so we can say statement 3 and statement 4 are absolutely right, correct or not? And also 1. These are the statements are right. I hope this is clear. So we'll move on to another question. Try to solve this question, ma. I'll be giving the 2 minutes of time. So let me give 3 minutes. You can some calculation required. Try this question, all of you. Yes, I hope you are trying, all of you. I hope you are able to do it. So 0.104 milliseconds. What about other people? Any other people are trying? Yes, anybody tried? So node X, so transmitting the data to Y, correct or not? Y. This router R is there. Now we need transmission delay, correct? Then propagation delay will be there. At router, queuing delay plus even processing delay we have, correct? Then followed by again transmission delay. So transmission delay I am taking TD. Then propagation delay will be there. Now finally you can reach the packet, right? This data packet, right? Thus distance is given 4 kilometers, right? This link distance is given 4 kilometers. Am I right? Okay, now. So bandwidth also given. What is the bandwidth as given? So bandwidth has, so router R has a link L1, L2 connected X1 respectively. So now each link is 4 kilometer long, as the bandwidth of 2 gigabits per second. 2 gigabits per second bandwidth is given. Packet size L. What is the packet size L? And the propagation speed is given, and packet size 8 kilobytes. 8 kilobytes. 8 kilobytes. And the distance is 4 kilometers. Distance is 4 kilometers. So velocity is 2 into 10 power of 8 meter per second is given. So 10 power of 8 meter per second is given, correct? You can say yes. Then ignore the processing delay. Then the total transfer delay for the packet from X to Y in millisecond dash. So total time they are asking, correct or not? So can I say total time transmitting the packet from X to Y, correct, is equal to, I need 2 times of, can I make it like, transmission delay, propagation delay, can I say? So 2 times of transmission delay, 2 times of transmission delay, 2 times of transmission delay and propagation delay, correct, plus, so we need 1 time of queuing delay and processing delay. Queuing delay plus processing delay is required. I hope this is correct. Yes, everyone? Is this expression? Those who are watching, just confirm me. Now through which we can find the what transmission delay we can find, even propagation delay we can find it. Some of you tell me what the transmission delay you got. So L by bandwidth. So what is the propagation delay you got in terms of millisecond? The distance by velocity, distance by velocity. Yes, 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 respond. The value which you calculated by transmission delay, propagation delay. Mention ma, mention. So transmission delay 0.032 millisecond. So 0.032 milliseconds. Propagation delay is 0.02 millisecond, 0.02, so millisecond, okay. Then total time equal to 2 times of this value, right? So 0.032 milliseconds plus 0.02 milliseconds plus queuing delay, how much is given? Queuing delay as given 19 microseconds as given now. 19 microseconds. Queuing delay as given 19 microsecond as given now. So 19 means what? 0.019 milliseconds. Am I right? 1 millisecond equal to 1000 microseconds. So this become 19 microseconds, I can write it, correct? This value is right? Yeah. So now total time value, this is correct, just confirm me. Hanu 0.03, correct, 0.02, correct, Hamad 0.123, very good, okay. This value is subject to the whatever the value you calculated, substitute you will get. This is the standardized expression which you observed it. If more than one packet to be transferred, in case of more than one packet is there to transfer, then how the expression will be? Going to happen? If more than first packet, remaining packet will be what? only transmission delay will be there, correct or not? Suppose I am extending this expression, so total time, okay, total time equal to, okay, total time equal to more than one packet is there. So time for, please understand, time. So time for first packet transmission, first packet, correct, plus so time for n remaining n minus 1 packets. Let's take n minus 1 time for remaining packets. Simply I am writing time for remaining packets, correct, by using what? Pipeline concept, right? Using pipelining concept, correct. This total time equal to suppose now how many links are there? 1, 2 links are there. So now number of transmission delays how many? 2. So number of propagation delays are 2, correct. So now let me write it. So L times of, okay, so transmission delay, propagation delay plus, so L minus 1 time of queuing delay plus what? Processing delay will be there. Okay, this is the first packet transmission time, correct? Am I right, all of you? This is what? One packet. So now n minus 1 into only transmission delay because remaining constants will be there, right? Where so where L is, what is L? So where L equal to number of links or simply hops also we can call it, correct? Hops. Now n is what? Number of packets. So number of packets. Is it make sense, everyone? N minus 1 transmission delay for n minus 1 transmission delay, remaining only one transmission. This is only one transmission delay. Very good, very good. Yes, you can write it whatever manner. Variables are same. This is the standardized expression we can say under switching for the packetization. Understand, when you apply the packetization, so this expression, okay, just you can note all of you. Yes, anybody having doubt in this moment? Hamad, JP, even other people? Fine. Chalo, we'll move for other aspect. So now, as part of the test series, you understand, IMS we are offering the test series plus. The plus includes the two major components, you understand. What are the major things here we have? So 33 or 34 years of the previous year GATE booklet, which has the complete solutions, alternate solutions, important keywords, and even we have video solutions also, including mathematics and general aptitude, and also will be getting the access to the doubt portal session in which our all enrolled students are posted a lot of doubts related to all the topics. Then for that concerned faculties already detailed solution is given. So still you have a time, so because you will be getting more than 12 test series plus this all the things, and also will be getting subject chapters, all the test series you are able to access it. Okay. So as part of the course for the 26 program, so we started the batch for the online program for 26 as well as 27. So this course, please understand, containing more than 800 hours of the teaching hours, okay, evening hours, so evening classes, weekend classes, weekday classes, which can be conducted live. And apart from, you will be getting the each subject theory books. So synopsis has very important topics, the concepts wise, some objective questions, followed by for each subject, like chapter level questions will be there. Exercise book contains chapter level 1, level 2, level 3, like so basics question, moderate questions, are very advanced questions, so prepared for each chapter level for each subjects. The together more than 4,000 questions can be seen, and we believe that students can be they can be perfect in a subject when they do subject level tests, multi-subject level tests. So the subject level, chapter level, multi-subject level questions also can be seen along with this previous year GATE question, because for us authentication source is what previous year questions only. By solving many previous year questions, we can understand the type of question can be seen in the GATE paper, and the mindset of the IITians, how they want to frame it. So those cards can be observed with. Followed by important component of the IMS is what mentorship sessions, like 12 mentorship sessions can be getting to you, like that you can utilize throughout the what year. Okay, sir, IMS का all India mock भी होता है like that. So that's what I was telling now. This test series plus has the mock test plus booklet will be getting. Test series 12 all India mock tests, 12 all India mock test we have, which is same like a real gate exam. You will be having virtual calculator, everything is same only. So that is we have already launched. So it is like still test series are going, some tests are already live, some are tests are going to be live. So you can sit for 3 hours time and you can solve you should feel, you are going to feel like a real gate exam only, that level only questions will be there. So apart from this 12 mock tests, all India mock tests, other things also can be offered from the package of test series plus. So you will be getting the event discount also, you can contact. So I hope this is clear. So moving into this now, so next aspect will move quickly on IP header format and fragmentation. This is very much important, IP header format. This also, why sir? Either in this case you can expect the 2 mark questions possible. In this case 1 to 2, so 2 marks possible, because 1 mark or 2 mark questions can be framed here, and so I am just guaranteeing definitely there is a question, there will be a question 25 gate from this topic, because so when we observed, when 33 years of the papers, every year at least one question can be seen in this area. It's highly expectable area from computer networks is this IP header format and fragment, and easily solvable. And from computer networks, understand all of my dear students, some of the questions are time saving only, because suppose other subject you take operating system, computer architecture questions or algorithm questions, if you see, sometimes you need to spend and you have to spend compulsory to get the answers. But some areas we have in a computer networks, by looking at a question you are able to solve it. One area is application layer, other area is IP header and fragmentation, even some more areas also can be observed. So coming into the point, all the fields, please understand, all the fields, okay, the fields of IP header you must know, you should understand IP header, you should know IP header. Okay, can you tell me, some of you, what are the headers we have? So roughly, suppose first row, if you see row number 1, if you see row number 1, what are the fields can be seen in IP header format? The first we have what? A version, correct? Version size is what? 4 bits will be there, correct? Version only, followed by header length, right? Header length of what? 4 bits only, correct? Followed by type of services offering. Then total length of the datagram, this 16 bits will be there, right? So this is first row covering the 4 byte, 32 bit nothing but 4 byte, correct? This is 8 bit length, this is 16, this is 4, 4, 8, 16, total 16. Row 2, can you tell me row 2, row number 2, which has, one is identification number of 16 bits, correct or not? So datagram identification number, okay, and that is followed by what? A fragment offset field will have, right? So now say some more thing, like we have a flag bits, one is a more fragment and a don't fragment, 1 bit is not used, 3 bits, this is 3 bits, and followed by, understand, 13 bit of fragment offset we have, right? 13 bits what? 13 bits are fragment offset is there, right? Yes or no? Yes. So row number 3, the first we have a TTL, time to leave value, 8 bits will be there, followed by some protocol bits are to understand what type of protocols are keeping here, that is also 8 bit, and header checksum, only header checksum we have, so header checksum will be there here, header checksum of 16 bit, so this also 4 byte, right? 4 byte will be there, right? Yes or no? This is row number 3. So row number 4, what is the row number 4 we have? Source IP address will be there, that is also 4 byte long, correct? So row number 5, destination, so IP address will be the 4 byte long, okay. So this is a mandatory minimum header size, right? Minimum header size. So minimum header size 20 bytes, correct? Yes or no? So row number 6. So row number 6 we have what? Optional field. Option field of what? 40 bytes will be there, right? This is 40 bytes. I hope these are the things only majorly. Yes, yes, my all dear students, confirm me. So these are the fields can be seen in IP header, and I hope you know the meaning of each fields which they are talking. Then header length we use the scale factor. Yes or no? 2, because maximum header size possible 60 bytes. 60 bytes you cannot represent in 4-bit number. The scale factor we are using as 4, correct? Even one more thing also, offset value. Okay, maximum IP datagram possible 64 KB. With the 8-bit number you cannot represent. At the 13-bit number 8 KB possible, 64 KB you cannot use it. The scale factor it gives how much value? 8. Scale factor 8, correct? So like this you should understand the informations. Okay, okay, okay. So noted. Shall we move to some problems related to this part? Fragmentation will observe. Okay. Come to the point. An IP packet has arrived with the first 8 bits as very easy question, very easy question. So which of the following is or incorrect? Incorrect. You should read the question properly. Always you should read the question properly. You know, type of mistakes can happen. So silly mistakes means type of silly mistakes. If you see, the first type you understand, you know, we are not reading question properly, we do mistake. Second type of mistake, you know, we are reading properly, you know, but you are not able to apply properly in that formula. Second, third type, you know the fully understood question, you know the formula, you have substituted. While substitution, you are making a mistake, calculation make a third problem. Fourth problem, understand, you know, you are not able to understand because of some confusion over the concept, you are not able to get it. So not able to solve. So these are the 5 types of things which you are not, in which from this, you know, you are not able to solve the question. You are not able to attempt the question properly. You are not able to give a correct answer to the questions. Either one, any one of them. So losing your marks only. You have to be very careful while attempting the question. Tell me now, tell me. So 8-bit number is given, first 8-bit given. So which of the following is are incorrect? Yes. So I am giving only 1 minute of time for this one. You are able to solve it within 1 minute. I feel you are able to solve within 1 minute. Yes, tell me. So the number of hops this packet can travel to. So number of hops to means I do not have information because time to leave at row number 3 to go to row number 3 is very difficult. We have 8 bits are there. This is completely incorrect. Total number of bytes in the header length is 16 bytes. Now first 4 bits giving what? Version. This is IP version 4. So this is what giving what? 0010. 2. So 2 into 4, nothing but what you can say 8 bytes only it can tell, right? It is telling what 8 byte information, because square factor I have to multiply. This also incorrect. It is also incorrect. So upper layer protocol is ICMP. So I need ICMP protocol to be read here. So after TTL protocol 8 bit is there. So I have to cross 8 bytes, I have to cross it. Only 1 byte information. This also incorrect. The receiver reject the packet. A receiver reject the packet. So by looking this, how we can understand whether reject or not. So this also incorrect. All the statements are, D is correct. JP, D is correct. The receiver reject the packet. Yes, I think, sorry, yes, receiver will reject the packet. Is it true? Just think. IP packet has arrived with the first 8 bits only. 100% correct. Very good observation. IP packet received the first 8 bit only came, only 1 byte data came. With this 1 byte data, we are not able to get it, correct or not? Very good observation. So therefore, A, B and C are answer for this question. Very good observation. Vinay. Yes. So next, moving on to next question. So which of the following are true regarding DHCP protocol? Yes. So again I am giving 1 minute time only. You are able to solve it. Yes, work out. Yes, all of you try to answer the question. Yes, what happened? So DHCP can be configured to provide temporary on demand which required IP addresses to the host and routers. Is it true or false? Yes. Statement 1 is true or not? So you are saying that DHCP client server protocol, this is absolutely true, correct. So DHCP uses the services UDP, which is not real, that is also true. So DHCP message has 64 bytes as optional field, up to 64 bytes it can have. So this also true. This also true. What about A? A is not correct. Think JP, Vinay, Hamad, other people. DHCP can be configured to provide temporary on and demand IP addresses to the host and routers. Think all of you. The statement is true or not? Yes, yes. So what is your opinion on option A? JP, Vinay? What happened? What is the answer for? What is the no? Whether statement A is true or false? Statement A is true or false? So why it is maybe? Why it is maybe may not be like this? Where is the doubt? Where is the doubt we are getting? In option A, so what is the doubt we are getting in option A? What is the doubt in option A? So does routers has always permanent IP address? Will it not change the IP address of the router? Meaning suppose once you are able to contradict, generally we know for a host it will dynamically assigns. For host there is a confirm all demand means whenever they are active. So now DHCP server like that routers sorry you can understand the client has to put a request, so you will be getting dynamically temporary IP. That is true, but the point only you may be getting doubt on routers, correct? That is only so like configure to provide temporary and demand IP addresses to hosts and routers. Are you getting doubt on router, right? Whether router dynamically assigns or not? The thing you understand now, okay. So when is like suppose if I create my network, okay, my organization network, if I create it, in which routers can be configured, correct or not? So now router always like please understand one thing you understand, router always contain the permanent IP. Answer is no. It can change, IP address can be changed, correct or not? MAC address will be there, like MAC address will not change, right? IP address you can configure it. So when you change it, you have to update in the tables. IP address if changes means you have to update in the table, correct or not? Yes, this can change. This can change. This statement also true. This statement also true. Therefore, all the statements are correct related to what DHCP. So try to revise JP like you are not sure is saying what, still revise all the protocols because theoretical questions can be expected in this area. I hope everyone clear, Vinay and Hamad and JP. Yes, everyone. Required response, required response. Okay, move on to next question. So which of the following is are true? Again related to ICMP packet, just observe clearly. So I'll be giving a time for 2 minutes. You can try. This so this question wantedly framed it because a theoretical question can be seen, 1 mark questions can be observed. Yes, try to answer. This question is related to ICMP packet. Yes, what are the statements are true? Yes, yes, JP, Hamad, Vinay. It can be framed for 2-mark question. It has a potential to make 2-mark question. First you tell me known one, known questions, known statement you can tell, right? So fourth statement is true. So yes, to debug the network, ICMP packet is generated by the source. Yes, as a message request and reply format, we can send echo message, right? Echo request message we can send it, correct? Or whether the destination is reachable or not, the path is correct or not. So we can tell this is 100% true. So ICMP error message will be generated for each fragment which is lost at router. So I can straightforward, I can tell this is wrong, correct? Suppose fragmentation done, anywhere in fragmentation done, like fragments are going to different route, okay, different route going on. Each fragment is lost. For each fragment, ICMP packet will not generate. Example, one IP datagram is going on the network. One of the router fragmentation done into 10 packet, 10 fragments. 10 fragments are going different route assumption now. One of the fragment is lost. 2 fragment, 3, 5 fragment lost assumption. 5 ICMP packets are not generated. But 5 ICMP going to but same source only, correct or not? 5 ICMP is going to inform to the source, right? It is a duplicate in the network. Therefore, for each fragment, it will not generate. For each fragment, ICMP packet will not generate. So what like now for what fragment ICMP generated? Only first fragment, please understand. When IP datagram is fragmented, all fragments are maybe going to different route or same route. If first fragment, please understand, if first fragment is lost, for this only ICMP generated. Sir, other than first is lost, ICMP not generated. Then how receiver will come to know? Receiver and the network level try to reassemble, right? Reassemble time you are not able to identify the next fragment, right? Definitely. So that moment transport layer cannot be assembled. So that will taken care by transport layer. So we are not sending the ICMP packet for each fragment which is lost. So ICMP error message will be generated for each fragment which is lost. This is wrong. No ICMP error message will be generated for a fragment datagram that is not the first fragment. So can I say now statement 2 is true or false? Statement 2 is true or false? Yes, JP. Yes, JP. Hamad, Vinay. Statement number 2 is true or false? Statement number 2 is true or false? Answer it quickly. So this is true, is it not? This opposite statement only, correct or not? Next, what about this one? Statement 1, tell me, what is statement 1, true or false? Statement 1 is true or false? ICMP error message will be generated in a response to datagram carrying an ICMP error message only. So this is carrying ICMP, like let me take situation. Suppose some sender is there, okay, now router R1, okay, so router R2, router R3, suppose destination is their assumption now. So router R1 and router R2, router R3, okay. Suppose some datagram is coming from here, datagram, okay. So this datagram sent here, this datagram sent assumption now. Maybe this buffer is full, this is dropped assumption. If it is dropped, what you have to do? You have to generate ICMP packet, correct? ICMP. ICMP packet is error reporting to source, correct or not? Now, so what is the point? You read it now. ICMP error message will be generated in a response to datagram carrying an ICMP error message. So what does mean now? ICMP generated, right? ICMP is a datagram only now. ICMP is nothing but IP datagram only, correct or not? Yes or no, all of you? Because it is using the IP datagram services only now. Suppose in this moment now this buffer also full, right? So this buffer also full assumption now. This ICMP packet came, so you are not able to process it. You are not able to process because buffer is full. Now this ICMP packet is dropped. This is dropped. Now ICMP is dropped. Now will router R2 will generate the ICMP packet or not? Tell me, all of you. So data being dropped by the router R3, when a response to the data IP datagram, ICMP packet is generated. When ICMP going on and the router may become what? Router buffer can be full. In this moment router buffer is full, it can drop because any packet can be dropped. If it is ICMP packet least priority, UDP protocol also can be, UDP datagram also can be dropped, ICMP also can be dropped except the TCP, right? Now ICMP least priority packet came when the buffer is full, you can drop it. This can be discarded by the router R2. When router R2 discarding ICMP packet, will again generate the ICMP packet or not? Respond, tell me whether ICMP packet is generated by router R2 or not, then we can answer. If you know this one, we can answer the statement 1 is true or false. I need a response from everybody. Tell me, in this moment when this ICMP is dropped, for this ICMP, response to ICMP packet, another ICMP generated by this router R2 or not? Yes, respond everyone. Everyone. Dear my students, respond to the answer. Respond to this this part. Will it generate ICMP packet? So now ICMP packet generated to means what? It is informing to whom? Router R3 only. Now see. So router R3 when ICMP packet generated is saying like no, router R3 is a source IP address instead. Then so destination IP is what? What is destination IP? The IP address of source, like this I say. Now he header has like source IP address R3 and destination is what? This one. So that source can understand, okay, the packet is my datagram dropped by the router R3, we can understand now. When ICMP packet comes, so now it is dropped. Now if my question to all of you, carefully answer it. If router R2, this ICMP is dropped, now it's saying that creating ICMP. So if ICMP created, that ICMP packet will go to router R3 or sender? Yes. Where it will go? Question is clear? Huh? So as you are answered like sir, ICMP packet because it is dropped, we have to inform. So I generate the ICMP packet. If the ICMP packet generated by router R3, so now this ICMP packet will go back to router R3 or source. Where it will go? Where it will go? Required response. Required response. Router R3, very good, because his packet came from here only. Now suppose you understand one more ICMP packet is generated by this one, right? So it's saying that who is dropped? R3. Who is sending? I am sending to what? R2. Okay. Now it will send to what? Here ICMP send it. Now already buffer is full now. Buffer is full, right? Situation understand, again buffer continuously full assumption now. This can be dropped. Highly possible router R3 also can be dropped this ICMP. Respond. Required response all of you. Because router already has busy. Now any packets comes, it has to drop because ICMP is a least priority, it's going to drop. Highly possible, highly possible. Then as you told sir, whenever ICMP packet is dropped by any router, for this response you should generate one more ICMP. Now suppose you imagine one more ICMP generated here. So in this moment ICMP is what? Dropped by router R3, sending to what? Router R2. So both are forgot about sending to our source, correct or not? This goes to infinite loop. Yes, because they forgot, each other forgot to send to our source here. Therefore, what is the conclusion? ICMP packet taking service of datagram service. A datagram service is unreliable. Once ICMP packet is dropped, discarded by any router, no further ICMP is generated. This is very important point you should notice. Sir, why it is not generated? Since because I am not ensuring the reliability. When the reliability is not guaranteed, no further, because I don't want to create a more headache on the what network, correct or not? Therefore, once any router anywhere ICMP packet is dropped, no further ICMP is generated. This is very important point you understand now. Sir, source will never get to know anything. No problem. Next transporter will take care, right? Network layer, entire network layer is what? Unreliable, right? It is not guaranteed to be delivered into our destination. It can be dropped. It can be dropped. So therefore, in a response to the ICMP packet, no further ICMP generated. Now see, ICMP error message will be generated in response to datagram which is carrying ICMP packet. So for this not generating, this wrong. I hope everyone it is clear. Statement 1 is clear, all of you. These statements are completely based on the concepts only. Concept learn. No by-hearting required, nothing to be remember, nothing to be remember. Try to understand the concept well. You are able to answer the question. Yes, all of you, is it clear? Everyone. Next. So next question. Answer it. I hope you are able to answer in within 1 minute only. Yes, check. So what are the statements are right? Yes. ERP is a network layer protocol. Very good. This part of the network layer only. Helping to data link layer. Correct? Helping to data link layer. Correct or not? So transport layer and network layer. Correct or not? So data link layer. Right? Like this we have a layers. So now majorly TCP and UDP protocols are there. Correct? Now major part is what? IP protocol. Here is ICMP and IGMP will be there. So ARP protocol will be there and helping to what? Data link layer to get what? MAC address, correct or not? This is true. All ARP requests are local broadcast requests only. Is it not? Local broadcast, nothing but Within a network only they do broadcast. Outside the router it will not go. Outside the router further broadcasting is required. This is also true, correct? ARP replace what? Tell me. ARP replace or unicasting. Unicast in nature from the border router or maybe destination part of the network. ARP mapping what? IP address I know, IP address of the destination I know, part of my network. Maybe IP address of router I know, but I do not know MAC address. I need MAC address. This also statement true. So therefore, A comma B, C, D all are right. I hope this is clear. Everyone. Anybody having doubt? Hamad, where is a doubt from statement 1? Isn't it part of network layer? Hanu Hamad? Yes, JP, Vinay, I hope it is clear. I hope it is clear. Chalo, we'll move on to other parts. Okay, next question. So, I am giving 3 minutes time. Try to answer this question. Try to answer this question, ma. So, related to fragmentation. It is part of network layer but helping to our data link layer. See, JP, very simple clue I am telling you. In order to get a MAC address, have to know IP address, right? I am adding IP address of the destination. IP address adding is possible where? Network layer only, correct or not? IP address of the destination, maybe router or maybe destination, which in my network. IP address I am adding. My IP address, your IP address, both I am adding to given to a data link layer where destination source MAC we are adding. Destination MAC is all ones. So, destination MAC is all ones. Source MAC, destination all ones, and source IP address, destination IP address kept, and we are sending down broadcasting. So, IP address adding is possible in network layer. IP address of the destination I know, correct or not? I do not know MAC address. I do not know MAC address. Therefore, this protocol, so origin from what? Network layer only. Network layer only. Your doubt is correct, but you should have the clarity on this. Yes, ma. How many people were able to answer it? How many fragments will create at source? Yes, Vinay, Hamad. So application layer any size can come, but transport layer we are using this UDP, then network layer and data link layer, right. So data link layer, so what this told, that the payload, maximum payload given, right. So maximum payload as given, so 1500 bytes. Okay. So 1500 bytes. Let me maximum payload like this I am taking 1500 bytes. Okay. So this has to come from network layer only, right? This has to come from network layer only. This is coming from network layer only. But network layer also having what? Header will be there, right? Header will be there, right? Header and payload will be there. So this has to come from transport layer only, right? This has to come from transport layer only. You would understand like this. Okay. So transport layer UDP protocol is here. So what is the payload? Payload as 9880. So 8 bytes header will be there, and payload is what? 9880 is there. Okay. So in this comes 988 will come, right. This is a network layer IP datagram. Now what they showed here, UDP header 8 byte, the size of the IP header 20 byte, option field of IP header 20 bytes, 20 more is there. So overall I can say 40 byte header is there, 40 byte header is there now. Okay. So this all will come here, please understand. Now this payload maximum, so transferable unit is what? 1500 bytes is there, 1500 bytes only now. So this is including this has to come, please understand. This has to including it has to come, right. It is including has to come now, correct? This including has to come now. This I have to remove it. So including this 1500. Meaning 1500 nothing but 40 header nothing but. So 1460 plus 40 byte header has to come, correct? So you cannot carry more than this one. I have to do fragmentation. I have to do fragmentation now. So now number of fragments, how many will create? Sorry, number of fragments. So number of fragments. So number of fragments equal to, okay, payload. Payload is what? 9, whatever comes upper layer, 9888 by, okay. So this 1460, but does 1460 is divisible by 8 because you would use a scale factor. No, observe it. UDP source and a UDP packet which has 9880 bytes of data. This is data, please understand. This is a payload. To host B, payload size of the data link layer is 1500 bytes. Size of the UDP header is what? 8 bytes. Is it not? UDP packet has, which has 980 bytes of data. Data means what? JP, I hope it is clear. That is the reason we have to read word by word. As payload, whenever payload word or data used, only data part only. Payload is not include packet size. Whenever if I say segment, IP packet, when I say segment, data header is included. When I say IP packet, IP datagram, header data is included, both are included. When I say only payload, we are talking about data only. So you have to be clear. Very good. So this is the IP which I received it. On this only I have to do fragmentation now. So now tell me what is the nearest number 1460 which is divisible by 8. Yes. Respond. Because I should not divide by 1460. Should I divide by 1460? 1460 is header and data part 1460 only, but 1460 is not divisible by 8, correct or not? Tell me divisible by 8 nearer to this one, 1460. I am asking everyone. Respond. SJP not seen means gone, 2 marks gone. If you are not seeing that data, nothing but you are losing the marks only now. Yes ma, what is the nearest value? 1460 divided by 8. Okay. So 182 into 8. If I take 182 into 8, 1456, isn't it? 7 segments, 6 of the size 1460 payload, 40 plus byte header, and 1 byte data and 40 byte header. Okay, 1460 for 50s. This should be 56. So you will be getting how many? 6 point something. The 7 fragments required. 7 fragments. So now last fragment total length I need. Last fragment. So last fragment total length value will have data plus header of 40 bytes will be there. So data, how to calculate this data part, you know. So 6 times 16 into 6 times of 1460 minus 988 you have to do, correct? What is this value you got? Tell me. This value, can you please tell me? 180 6 times of this only, correct? You can do, if you are getting scale factor, that one also correct only. 183 into 8, 1152 you are getting, okay. So 1152, so 1152 plus 40 bytes, so 1192, correct? All of you got 1192 only. So 7 fragments, 6 of size 1450 payload plus header and 52 byte data 40 52 1192, correct? Total length nothing but always total length will be what? Payload plus header will be there, right? Confirm me finally everyone. This value is correct. This absolutely right. First thing, number of fragments are 7, correct? So this value is correct? Yes. Be careful, 2 marks question is possible here. So offset values, first segment, third segment, like varied questions can be asked. So be prepared in that area. So next, moving on to another important aspect here. Here majorly you need to focus 2 routing algorithms which are dynamic routing algorithms. One is DVR, okay. The second one is what? Link state routing algorithm, DVR and LSR. DVR, LSR need to be focused, okay. So now some information related to this one, if I talk, some information, okay. So DVR, please understand, so some points I can write, it is based on what? Bellman-Ford, right? Bellman. So Bellman-Ford algorithm, correct? Bellman-Ford algorithm, basically, okay. It is also, we can say, local routing table. It uses construct the local routing table. It can, and it has a problems. One is, you know, count to infinity problem, yes, right? Count to infinity problem as well as what? Looping problem. So because of this count to infinity, looping problem is there. This information we captured it. Then solution, what is the solution we are using? This one, split origin. So split origin is a solution to remove these 2 problems. Okay, now it is slowly converges. Converging is what? Very slowly. So why, sir? We required how many rounds? N minus 1 rounds. So maximum N minus 1 rounds to converge it, where N is the number of nodes. Correct? N is the number of nodes. N minus 1 maximum rounds required to converge it, because 1-2 rounds it won't happen, right? So now basically this also intra-domain, please understand, intra-domain routing only. Intra-domain, so domain routing only. routing algorithms, routing only. Intra-domain means within a campus only you should use it. Okay, it takes the like no, it will send neighbors, correct or not? Neighbors like DVR, distance vector exchange neighbors only. Distance vector exchange to what? Exchange distance vector exchange among what? Among neighbors only. Among neighbors only. This information we captured it. Among neighbors only. And understand this, so sending this distance vector, it is using the UDP services. UDP services only na? UDP services, correct or not? Now distance, DVR is a concept, right? So DVR is what? Concept. So DVR is a concept. So this practical implemented our routing information protocol, RIP, correct? Routing information protocol, RIP. Very good. This information can be captured, DVR, about DVR. So this looping problem, so looping problem is what? Persistent. Persistent looping problem it has, correct? Persistent looping problem is it has, right? Yes, RIP, routing information protocol. Now it maintains hop count as hop count. So metric as hop count, okay. And maximum hop count is 16. This 16 indicates what? Infinite. Because whenever two nodes are unreachable, the distance costs infinite conceptually, but that is being implemented by what? In what? So the 16, correct. This is about DVR, right? DVR, right? DVR. So now about LSR if you talk, link state routing algorithm. It is also dynamic algorithm, right? Dynamic algorithm. So what is the meaning of dynamic? Periodically, please understand. So periodically what? Routing tables updates, no? Routing tables updates. Periodically routing tables updates. In this, in a DVR also periodical updates only, right? It is constructed based on the what? Global. So global knowledge, that is a local knowledge, global knowledge. Okay, please understand now. Global knowledge is now it has a neighbor information sharing to all. Very good. It is uses directly Dijkstra. So Dijkstra's single source shortest path, correct? So due to this one, conversion is what? So converges fast. First round local state information construct. So next round it will be every router make their own routing tape network in its memory, correct only. So now my opinion, converges fast nothing but in second round we apply Dijkstra algorithm, make it stabilize the network. That's what converges fastly. So it also having some looping problem, please understand. So looping problems, some black hole problems will be there. So black hole problems like this, which are transient, not permanent. Transient problem. These all are transient problem. Looping and black hole forming is transient only here. Okay. So now here is some issues comes, like some problems will be there. What is some problems? Related to flooding. It is based on what? Flooding concept, right? Flooding is used. So flooding used, please understand. Because of this flooding, what? Traffic is what? Traffic is what? High, correct or not? Traffic is high now. Traffic is high. So it is more complex also, please understand. Traffic and complex also, more complex. Implementation is more complex. And computation now required more, right? So due to flooding, some problems will create. What are the problems? In a duplicate packet sequence comes into picture. So this duplicate packets avoiding, no, we use a sequence numbers as well as time to leave value also. So both I can add it in my routing table, so we can solve this problem. Very good. So LSR is a concept practical implemented open source. What you can say? Open source. What is OSPF stands for? What is the OSPF stands for? Yes, yes, yes. What does S stand for? Source or shortest? Which one is correct? Yes, ma. Yes, yes. So we mentioned Dijkstra algorithm clearly, and some more points also we can tell what it is also intra-domain routing, intra-domain, domain hierarchical routing also we can say. Hierarchical routing also can sell. It uses a services of what? Uses of IP datagram only. It won't use any UDP or TCP. Correct. Open shortest, not source ma. This is open shortest path. First we can tell. Yes, these are the information can be captured. Okay, about LSR. Very good, very good, very good. Moving on to the problems. So moving on to the problems. So I hope you are copying. So are you taking a screenshot of it, ma? Take the screenshot of it. Very good, JP. The points which you mentioned all are correct. All are correct. Very good, very good. Chalo, we'll solve. Move on to this one. Yeah. Take the screenshot of it. Everyone, which is important points only observed, right? Yeah, try to attempt this question, ma. Just 1 minute time only. I am giving a time 1 minute, just 1 minute. You are able to solve it. So which of the following statement is are true? Yes. So all are correct, you are saying. So in LSR traffic is more, that is true. So flooding in LSR can be controlled by using sequence numbers and TL value. Looping problem is persistent problem distance vector, that is also true. Black hole problems, transient problem in LSR, this is also true. Temporary, this problem can be resolved immediately. Very good, very good. All are right, all are right, all are right, all are right. Next question. Count to infinity is a serious problem in a distance vector routing algorithm. Which of the following statement is are true? Again, you can able to answer within 1 minute only. One more questions, highly possible. One more questions, highly possible in this area. Yes, what are the statements are right? So Vinay is telling B and C. So B is in split origin technique, convergence is faster, very good. B, and one more you are given C. C is looping problem is no longer exist in a split origin strategy, is used in DVR. If we are using if we use no longer exist if a split origin strategy is used in DVR, so no looping problem. This also true, very good. So what about A and D? So split origin technique removes a count to problem partially. It is fully removes, correct or not? It not partially, therefore I can remove this one. Looping problem is no longer existed if a split origin strategy use LSR. LSR does not require to apply what? Split origin problem, it is split origin technique. This is also incorrect. Therefore I can say B and C are right. B and C are right. Very good. Very good observation. Very good observation. Good. Oh, okay. Move on to next question. Take this data. First to take the screenshot. I'll put the timer. Consider 4 routers are connected in a certain framework as shown below. Link between R4, R5 got broken. Link between R4, R5 broken because of certain undesirable circumstances. So I hope it is visible. Router R1, router R2, router R3, router R4. R1 to R4 link cost is 3. So R1 to R3 link cost is 2. R1 to R2 link cost 4. R4 to R5 link cost 5. R4 to R5 link cost 6. And the distance vectors given. It is stabilized network only. Take the data. I hope this is visible, everybody. Is it visible? Should I read it? The values are visible, everyone. Yes, ma. Yes, ma. Did you note the data? Okay. So I hope you copied. Then what is the sum of all values of distance vector at router R3 after 2 rounds of exchange by using DVR algorithm? DVR algorithm. Okay. So I am giving the time for 3 minutes. Tell me. So data copied, all of you? Did you copy data? Yes, very good. Noted. Okay. So now work out on this problem. What is the sum of all values of distance vector at router R3 after 2 rounds of exchange by using DVR algorithm? You can able to solve it, work out. I hope you know the framework of the DVR algorithm. Yes. Anybody solve this question? So let's attempt it this one. Observe it. When the link is broken, please understand, link is broken, immediately what happens, at router R4 will update about router 1, 2, 3, 4, 5. This is going to update it as infinite, correct? Immediately our router R4 is going to update it, right? Am I right, all of you? I hope it is visible. I hope it is visible. Infinite is updated now. So now one round of exchange means what? So now I am looking at router R3. Router R3 neighbors are what? R4, R5. So this distance vector exchange, this distance vector exchange. New distance vector I have to calculate at router R3. So router R3, new distance vector I have to calculate. So I am only worrying about this information about router R5 only. That's only required because remaining may not be changed, You can observe also, may not be changed. Let's see the points here. So this comes into picture, this also comes into picture. So 1, 3, 1 is minimum, 1 plus 2 is what? Okay, this is R1, R2, R3, R4, R5, correct? So this come into picture, this also come into picture now. So 1, 3 minimum, okay, minimum value is what is the value? 1. So now 1 plus 2, 3. So what it changes? Anything changes here value? So next comes 7, 0, 0 plus 2, 2, correct only. Next comes 5, 5, 2, 2 is minimum, this is going to be, so like, sorry, R2, 2, R2, R3, 0, then 0, 7, 0 plus 5, 5 only. Next is infinite, infinite comes 13 plus 2, 11. So how this might happen? 6. So this is before construction was 5 and 2. Thirteen, 6, 6 is minimum, 6 plus 5 is 11. 11 is constructed. Yes, yes. Anybody solve? 4 plus 2, 6. 4 plus 2, 6. You are saying here is a 6, 6 remaining. Sir, from R1 to R2 is 4. From R1 to R2 is 4. Okay, this you have to take, right? 4, correct. 4, 3. 3 is minimum. 3 plus from R1, what is the neighbors we got? Neighbors which updates from R4, R2, correct. So will it change any value here? R1 to R2 is 4, R1 to R2 is 4, correct only. So my question to one round of exchange, what is the new routing table at R3? Then we can apply for second round. JP, are you there? Vinay and Ahmad? So 320515 after one round. After one round. Okay. Anybody? Anybody? Because 2 neighbors comes, I have to take 1, 3 minimum. So 1 plus 2, this is going to be 3. Very good, 3. Very good, very good. So that remaining 2 only, that remaining 0 only, that remaining 5 only. So this is going to be 15. Why? Because you are sending 15 infinite here. You are sending what? 13. 13 is the minimum. 13 plus 2, 15. So this is going to be changed to what? 15. Very good. Okay. In second round, so now it is, we have to update these 2 routers also, correct or not? This I have to update here because later is a neighbor. For this neighbor is this one here also. Now what about this one? After one round at R1, R4, R4. So it is sending 0, it is sending infinity. 0 is minimum, 3 correct only. Is sending 4, it has what 7, correct or not? 7 only is there. So minimum is what 4, 4 plus 3, 7, correct only. So now sending this neighbor, sorry, this is also sending 2, 2 plus 5, 7, correct only. Then 0 we are sending, here is sending what third value is sending is 6. So another neighbor is we have, correct? This is 5 only, correct? This is going to be, what is the round 1? Tell me now. After one round, content of R4, after one round R4 value, required response everyone. After round 1, R4 distance vector, R4 distance vector, distance vector. It send 5s, it send 3, it send infinity, 3 is there, 3 is sorry sir, 9 plus 3, 12. I hope this becomes 12, correct? This infinity going to update at 12. Am I right, all of you? Yes, required response, work out. So at router R4, after one round, what is the new distance vector? For router R1, neighbors are what? R1 as well as R5 also, as well as R3. All 3 values you have to take, minimum you have to calculate. Because existing values only will be forwarded, correct or not? So before value was 6 only, right? This value 6 only will be there. 6 will be there, here is 0 will be there, 9 is there. So 0 is the minimum, 3 only, remaining 3 only, very good. So next is sending 4, this is sending 2, that is sending 13. 2 is the minimum, 5 plus 2, 7 is correct only. Sending 6, this is sending 0, sending 11, 0 is the minimum. So 0 means this will be anyway 0 only. Is sending 9, it is sending 0, is sending what 11, 0 is the minimum, but that is infinite is there, right, correct or not? So now I can take this value is 11, now this has sent 9. So 9 is the minimum, 9 plus 3. This becomes what? 3 will be there, 7 will be there, 5 will be there, 0 will be there, 12. Very good, very good. One round. I need only these 2 people, right? Now apply. Now what about you have to update here? Tell me now router R2. Router R2 after one round. We can do here only, right? Not further, so taking data. Now here only. Router R2 after one round. So this R1, R3 came into picture. That was came 6. 0 is the minimum. So 0, isn't it? It has sent 0. Some values, what are the existing values only I should take it here. Existing values only I should take it. This has sent 0. This has sent what? 6. 0 is the minimum. So this becomes 4. Is it 4 only? Respond everyone. I am asking after one round, distance vector router R2. Distance vector router R2. Whatever they send, based on this only new routing table we need to construct. Based on this only we have to construct the new routing table. Sir, you are saying that for router R2, 1, 0, 4, 1, 2, 3, 4, 5, 10. Okay, 1 minimum 1 only, 1 0, 1 0 correct, 1 router 1. Are you sure 10, how 10 will be there? Because is passing 11, is passing 9, passing 9, 9 plus 3, 13. Now no, it is not 10 I guess. Check, JP check for router R2. Vinay, Hamad. So 9 plus 1, you are telling 9, where is 1? One 0 4 7 13, 1 0 4 7 13. Sir, R2 to R1 1, so minimum 9 comma 9 plus 1, 9 plus 1 and 11 plus 2. So you are saying that this must be, this value should be 1, isn't it? Isn't it this one? Correct, JP? Respond. But they given as 4. So that 4, here also R4 to R3 if you take, R4 to R3 5 only, R3 to R4 correct only. Now R2 to R3, R2 to R3 2, R3 to R2 2 correct only. This is printing mistake. Correct only, this is printing mistake because it is updated as 1. R1 to R2 is what? 1. R2 to R1 also 1 only. R1 to R2 0 only. Acha, here is going to be wrong. You are saying that R1 to R3, R1 to R3 is 6 as given something. But we cannot change, correct or not? JP, whatever this cost is there, we should take, no? This is a cost as what? This cost was what? 4 only I should take, correct or not? 4 only there, right? It is passed as a vector 3 comma, I am writing, no, this 3 we got, 0 we got. So finally you tell me, Hamad, what is the distance vector totally? Vinay, I hope you are also doing, because it is talking about R1 information 3, it is talking about R1 information is 0, but I should tell 4 actually, but telling this 0 plus 0 is a minimum. So 0 plus 4 is what? 4 I should take it, isn't it? I should make it, this value is updated to 4. It is past 2, it is past 4. So minimum 2 plus 2 4 only, but R2 0 only. So this is past 0, it is past 6, 0 plus 2, this is correct only, 0 2. Then it is past 5, this is past 3, 3 is a minimum, this becomes 7 correct only. It is past 11, it is past 9, it is past 9, it is past 11, 9 is a minimum, 9 plus 4 is 13, again 13 only will be there after one round. No, you see this one, it is passed as 0, it is passed as 6, minimum is 2 only. Carefully observe, this is your routing distance vector at router 2 after one round. after one round. I hope it is clear, correct? Just verify things which I have done correct or not. Now whatever distance is there, you should take it like this. Maybe initially configured like this, but just take it given. See, vectors already given, na? Given only I should take it, right? So is that passed as 2 at router R3? I think. So sir, that passed as 2 at router R3. Router R3 passed 2 only. Yes, is it? About what? About what? So our vector came 620511 only it came. 620511. So 04639 came only. By using this I have to update. 0, 6 is minimum 0, 0 plus 4 is what? 4. At router R3, R1, R2 are 62. So 2 plus 2, 4. Correct. So JP, are you getting JP? So vectors comes, you see and update it, that's it. Don't touch anything, like whatever it is there you have to take. One round over. So next round of exchange, what happens? This is updated one. Okay. So next round of updation means for this router R3 only we need. Okay. So we are not looking for other things. This has to come, correct or not? So it is coming 3, it is coming as 4. Minimum is what? 3. 3 plus 5, 8. So this is going to be updated. Sir, 404713. 40. About R3 you are talking. About R3, it is passed as 0. It is passing as a 0, right? Anu Ahmad, you see R1 information, R2, R3 information, 0 is passing, right? It is passing as what? 6 is passing, minimum is 0. 0 plus 2 is 2 only, isn't it? 2 plus 2, how 2 plus 2 will be 6, 2, at router R1, R2, R3 like this. No, for me R2 neighbors are 2 neighbors only. One is R1, other is R3. R1 vector, R3 vector as it is I am taking now, correct? Now minimum about R3 to 0 has passed. So 2 only, here is passed as 6. So 6 comma 0 is minimum 0, 0 plus 2 only, correct only. Sir, at R1 to R2 1 and R2 to R3 2, R2 to R2, R2 to R2. So we take it as R1 to R2 minimum of 10 plus 0, 6, correct. So 1, 0, 2, 4, 10. My dear JP, R2 to R1, R2 to R1, please see, wait, how much is given? How we can take 1? It is given as 4 only, na? Isn't it? R2 to R1, what is the weight as given, JP? R2 to R2 always 0 only. Please understand, R2 to R2 0, self is what? 0 only will be there. Are you getting? Suppose I am calculating at R1, something R2 assumption now. So now R1, okay, R2, R3, R4, right? So like R5 if you take, R2 to R2 0 only, na? So distance vector 1 is given, you have to update existing distance vector 1 is there. That you have to update, right? These are the existing database. So I am going to construct applying one round. I am new routing table I am constructing. This existing routing table I have to update by taking the neighbor information only. R2 to R3, 2 only, very good, that is true only. So now when this information right now we have 1, okay, 2, 7, 13 is there, okay. Now I have to construct the new routing table. So for this R2, what is the neighbors? Neighbors are R1. So neighbors are R1. So another neighbor is what? R3. Correct or not? From R1, what is the information we received it? 404639. From R3, what is the neighbor information we received? 620511. By looking at how to construct, correct? Yes or no? R3 to R3 0 to update distance vector of R2. So now let's observe it. So now we are updating this one. Minimum is what? 0. Minimum is what? 0 telling, right? R2 is telling that R1 to R2 0, correct? R2 to R1 is telling 1, R1 3 to R6 6. Minimum is what? 0. R1 I am reachable to 4, correct or not? So now I can update what this value is what? 4 only, correct? I am updating this value is what? 4 only, because R1 to R2 4 only now as per this vector. Yes, 4 only. Next, this is telling 4 is telling 0, this is telling 2. Minimum is what? 0. So 0, R2 to R2 0 only, na? R2 to R2 0, fine, that is done. Next, I have to update this what? So this is 6 is telling and this is telling what? 0. So 0 I have to take, but 0 plus this distance is 2. The still 2 only, this is updating to 2 only, this is 0 only now. Now R3 information is telling 3, this is telling what? 5. Minimum is what? 3. So 3 plus 4 is 7. So 7 only, no change. Now 9 is telling is 11 is telling. 9 is minimum. So 9 plus 4 is what? 13. So this is going to be 13 only. Make sense? Sir, in R1, own that last R2 to R5 change in round 1. In R1, R1 to R5, in R1, no changes value we are not, R1 to R5, R1 to R5, R1 to, sir, in R1, okay, own that last R1 to R5 changes in round 1 only changes. Now after round 1 what happens? Immediately when infinite is updated, after one round this value is updated, because these people will pass the information. 9 is passing, 11 is passing, 0 is passing, correct or not? So it will pass infinite, he will pass 11, he passed 9. So 9 is the minimum, 9 plus 3 what? 12 only, 12 is updated. So JP, how in R4 uses the update value of 3 plus 4, we can have to use 1 plus 4, okay? In router R4, I met router R4, okay, router R4. Let me, okay. So how R4 we use the update value 4 plus 3, router R4, I met router R4, we use update value of 3 plus 4, we have to use 1 plus 4. Which value, how in our router R4 we use 3 plus 4, 7. How I used it, this passed as 0, this passed 9 something, this passed 3, correct or not? 0, this original value 6 was there, 9 was there, 0 is a minimum, 0 plus 3, 3 only we did it. Next it is passed 4, it is passed as 2, it is passed 13. So 2 is minimum, right? 2 plus 5, 7. We are not added 4 plus 7, don't misunderstand. We added 2 plus 5, 7 we added, because minimum value is 2, correct. Now I am coming to the Vinay question. So Vinay was saying, sir, R1 won't that R1, I met R1. So R1 to R5, R1 to R5, okay, how would this value is? R1 to R5, 9 has given, okay, he has given 9, so 9 only I am taking. So I am not touching actually, I am not looking at this, whatever given value I am passing only. So don't make it a lot of confusion, simply existing network, because they did not say stabilized network. Network is not stabilized. Network is not at all stabilized. They did not mention anywhere in the question network is stabilized. Very simply whatever existing vectors are, you exchange it, that's it. Achha, you are telling 7. How 7 is updated? This was 3 passed, this is 5 is passed, right? 5 is passed. Minimum is 3. So minimum is 3 means 3 plus 4 only I did, correct only. JP I did same only, no, see. This is passed as 3, correct? So this is passed as 5. Minimum is what? 3. 3 plus 4 is what? 7 only updated. 7 is not going to change. JP, I hope it is clear. I hope I answered your question. Because of the verbal statements, I am not able to synchronize immediately, but I understood because it is passed as 5 about this one, R3 information, it is passed as 3. Minimum is what? 3. 3 plus given by R1, so that I have distance 4. Good. Now apply round 2. Apply immediately round 2. So round 2, don't take this updated vector, just you take an update here only, correct? Round 2. Okay, very good. Now round 2, apply the round 2. So round 2, now 4, it passes about R1 information, right? R1 information, 3, 4. 3, 4, 3 is near, 3 plus 5, it becomes 8, correct? Now it passes about R2 information 7, it says 0 only. So now 0 I have to take. So 0 plus 2 is 2 only, so no change here. Next R3 0 only. Next about R4 information, it is passing 7. R4 information is passing 0. 0 is the minimum, so 5. So this is 5 only. Next passing as 12 is passing as 13. 12 plus 5 17. So this is a new routing vector, correct? Correct, all of you? This value is correct or not? Sir, why 8? Okay, did I do any wrong things? R3, R1 information, E has passed as 3, correct? Let 3 has passed. E has passed as 4. 3, 4, what is the minimum? When I tell me, E passed as 4 about R1. E passed as 3 about R1. Minimum is what? 4, 3, minimum is 3. 3 told by R4. So now R3 can reach to what? R4 with a distance of 5. 5 plus 3 is what? 8. But you can ask me question, sir, actually 2 plus 4, this is only near now. Why you are writing 8? That is not happen one time, right? After many rounds it will be stabilized, right? After some time maybe stabilized as 4 plus 2, 6. So 4 plus 2, 6 can be replaced by later. We are not at all taking this stabilized network. Many rounds required to stabilize. Whatever information passed, I have to update. Isn't it, JP and Vinay? Yes, everyone. Is it correct? So Vinay, is it clear why it is 8? You may be getting, sir, 4 plus 2, 6 only near, correct or not? That is 3 only. We are passing as 4 plus 2, 4 passed. That is past 5, correct only. Yes, correct only. Yes. Okay. So finally, what is the answer now? What is the finally answer now? The sum of the values only now? Yes. Tell me the answer. Is 32 is correct? Yes. Some of the values only they are asking. Correct. But little some questions you practice related to this one, ma'am. So related to this question, this part, try to practice some more questions, you will get a clarity. Correct? I think something mistake we have done, I guess. Some mistake we have done, correct? What is the mistake? We have done some mistake, I guess, ma. Sorry. Some mistake we have done. Sorry, ma. Sorry. These values are passing 3. It is passing as 3. It is passing as 4. So, sorry, ma. I think we did some wrong calculations. Extremely sorry, because actually minimum you have to take it what after adding this value, correct? After adding the distance value, correct or not? Because 4 plus 2 something, 5 plus 3 something, after adding minimum vector I have to take it. Oh, we did some little mistake. Okay, mistake we did. Okay, no problem. So now just making sure this one. Okay, now this also values are this little I need to change. So anyway, this is correct only. This infinite passed here. This is passing as 13 comma this is 15 only, correct only. No doubt on this one, 15 is correct only. Now second time, now here information 0 plus 2 4. Now 2 plus 6 is what? 2 plus 6 is 8. The minimum is I have to take 4 only. This is correct only because it is passing as this information 4 only. Now 4 plus R2 to R2 0 only. R3 6 plus 6 is passing, correct or not? 6 plus 4 10. This 2 plus 0 is what? 2. This is correct only. This value also correct. It is passed at 3 plus 4 7. Now it has passed as 2 plus 5 7 only. This is 7 only, correct. Now it has passed 9 plus 4 is 13. 11 plus 2 is 13. So no change. This is correct only. Very good. This point is no doubt of this one. So small updation here. These values are correctly we got. Now second round updating here. In a first round also, if I take this neighbors all, this value is also correct only, correct? Now see the point. 3 plus 5 is 8. Now E passing information 4 plus 2 6. So this is no change, 6 only will be there. Minimum. After that minimum I have to do it. Next 0 plus 2 2. Here is 7 plus something, 2 only, correct only. This is 0 only, correct only. Fourth one, 7 plus 2 9 passing. Now 0 plus 5 5 is passing. So 5 only will be there. It is passing in 12. It is passing 13. 12 plus 7 17. 13 plus 2 is what? 13 plus 2 is what? 15. 12 plus 5 is 17. So 15 is value. Some mistake has happened. My side only. Extremely sorry. Don't get confused. You are right only. Minimum you have to apply. Passing information plus the distance you take, and then you have to apply minimum. You write 2 plus 6 like this. So 2 plus 6 comma 4 plus 0. Minimum you have to take it. You guys are right only. Okay, now so finally I am telling 6 2 0 5 15 15 plus 20. This value must be 28 only, not 32. Extremely sorry, but I could able to rectify now only. But if would I realize after some time it would have been wrong. Is it clear? JP, Vinay, Hamad. 28 is the final answer, ma. 28 is the final answer. Some mistake what we have taken, that's what first minimum capture. Like I just know you minimum take and add it. After adding only should take it. Distance you see and add and make it. So I hope you understand the concerns. Everyone. So this final very simple logic is you take two distance vector value, add their distance, minimum you should take it. Very simple I am telling, suppose this value if to update it, passing 0, passing 6. 0 plus 4 distance is what? 4. 2 plus 4 is what? 8. Minimum is what? 4 only. Like this you have to update. This is only clue. So you have to apply for everything. Okay, I hope you understand. So chalo, we'll move on to other part because it takes time. Now, can you answer this question? Can you please answer this question? So which of the following is true about distance vector routing algorithm? So human errors are possible, but rectifying is important. Immediately we should rectify. We should not go with the wrong concepts. Okay, fine. Tell me. So router continuously tells all its neighbors what it knows about the internet. DVR algorithm uses the Dijkstra algorithm internally. Every router receives the periodic update from its neighboring routers. DVR uses a Bellman-Ford algorithm internally. Some straightforward statement can be make it true or false. DVR uses which algorithm? Bellman-Ford. This is true. So this is wrong. Correct? Every router receives the periodic update from its neighboring routers only. Correct or not? Periodical update in DVR. This is true. Routers continues tells to neighbors what it knows about internet. This is also true. Correct? Whatever this has information, it will forward. So I hope A, C, D, very good. A, comma, C and D are correct. These are the statements are right. True. So Vinay, C, D and A also correct. Vinay, A also correct. A, option A also correct, because so neighbors only gives information, correct? Through neighbors only we are understanding, right? Okay. Now next question. So which of the following? No, this we have already done. Correct. This is already done. Okay. So now moving on to the TCP as well as the UDP. So under transport layer, please understand two important protocols you need to be focused. One is a TCP, other is what? UDP. Other is UDP, you should know. Other is UDP, correct. Now, but we are studying here TCP as well as IP we are studying, correct or not? IP I am writing now. What is the importance of adding IP? Please understand now. Alone port numbers are not sufficient to establish the connection. But generally transporter deal with what? Port numbers. We use the source and destination port numbers. But alone source and destination ports are not sufficient to establish the connection with the server. Therefore, I need a support from IP internet protocol, that is IP address required. Combining of source port number, please understand, comma destination port number comes from transport layer, source IP address and destination IP address comes from the network layer. You have to combine 4 parameters. Therefore, we call TCP IP. So combining this all parameters also we call what? Socket. We called socket. So I hope it is clear. So the socket is a logical component which combines these 4 parameters. It is also size 48-bit size, you can tell. So 48-bit long will be the biggest. So source IP address 32 plus 16-bit of service point address only na. So please understand, source port number as well as the destination port number taken from what? Service point address of 16-bit. Am I right, all of you? So in which also like some well-known port numbers will be there, some random port numbers also chosen from range, that information you know. So that is the reason we called TCP IP. Other thing we need to study, but about TCP if you see, this lot of information. It is a connection oriented protocol, reliable protocol, end-to-end transmission, byte oriented protocol, byte stream protocol. Every byte have address like sequence numbers, we use it, correct or not? So many information you might have studied. Quickly move on to the question, some then we can observe it. Tell me which of the following statement is or true regarding the flow control at a transport layer. So observe it, observe and answer, because I am just focusing on conceptual level things which help you to solve the MSQ questions if they come in this area. Because numerical answer question solving very easy, because you know standardized formulas are there, you know the data, we can quickly substitute, you will get the answers. But we do some like mistakes, especially you know conceptual based questions, like conceptual based which framed as MSQs. Tell me many statements I kept, what are the statements are true with respect to this one. Yes. Stop and wait protocol is a connection oriented protocol that provides the error control as well. Am I right this one? Because stop and wait ARQ giving what? Error control mechanism. We got retransmissions we have, right? Yes or no? This is true. In stop and wait protocol, the acknowledgement number always announce the sequence number of the next packet expected. This is also true, because when you are sending a data packet, data packet 0, we will be getting ACK number as 1. We can implement stop and wait protocol by using only 2 sequence numbers also, right? That is also true. Now TCP may receive the packet in any order, but in order byte by delivered to ensure the TCP, correct or not? This is also true, is it not? It can receive because it is supporting what? SR protocol. SR protocol, major implementation of the TCP is SR protocol plus GBN also there will be there. GBN also will be there, but SR protocol is supporting, since it can accept what? Out of order packet, but delivering will be serial only. TCP uses random initial sequence number. This also true, isn't it? Because if a sequence number if chosen from zeros, that will create a problem or duplicate sequence number at receiver. So we use random initial sequence number. So this says other than 0 you have to start. So this is true. Fourth also true. Fifth one. So stream control transfer protocol is a new transport layer protocol that combines the features of the only TCP. Out of order allowed, but transfer in order upper layer because of SR and GBN. Because of SR, not GBN. JP, please understand, GBN will not accept the out of order packets. GBN will not accept the out of order packets because of SR only. So what about this one? So this I am marking, this is also true, this also true, this also true, third one also true, fourth one also true. What about fifth one? So fifth one, is it true? Fifth statement, stream control transport protocol is a new transport protocol that combines the features of only TCP. Talk about, all of you talk about fifth statement. Fifth statement. Fifth statement. Please understand, our stream, it is talking about stream. Stream control transport protocol is combined the properties of TCP, means what? You can tell directly TCP only, right? Why I should call SCTP? SCTP, why should I call? Simply I can tell TCP only. Transport layer having majorly we can tell 3 actually, but majorly popular 2. One is UDP, TCP. But if it is using only TCP properties, we can tell TCP only. What is the need of telling what SCTP? Please understand, this is a message oriented protocol. Please understand, message oriented protocol giving a reliability. You understand? TCP is a byte oriented protocol, byte by byte. UDP is what? Message oriented protocol. It is not giving reliability, correct or no? No reliability UDP. connectionless communication. But in some applications, sir, I want to send data in message wise only, but I want to secure, I want reliability also. Therefore, combining UDP, TCP, combining the UDP principles as well as TCP principles, the new protocol made, that is nothing but stream control transfer protocol. It is combining both. It is combining both UDP, TCP, both combined. He has mentioned only TCP. Therefore, this is what incorrect statement. I hope it is clear. Is it clear all of you? So, we are sending continuous streaming I am doing, but I am guaranteeing what? So, delivery, they are guaranteeing delivery, the TCP used. So, combining of this one, it is expensive, you can understand, expensive. Clear? Clear? So, I hope these are the statements are clear. Everyone? Is it clear? Shall we move on? Next question. Error control at transport layer protocol is responsible for dash. Detecting error, discarding the corrupted packets. Error control. Corrupted packets are discarded by the receiver and sending acknowledgement, correct or not? Negative acknowledgement in case of SR protocol. So, this is true. Keeping track of lost and discarded packets and retransmitting them, yes or no? Because until acknowledgement comes or until no acknowledgement comes, packets are at sender only, correct or not? If the packet is lost, how sender knows the packet is lost? The sender will wait till timeout time. Till timeout time, if no response came, so then will retransmit it. This also true. We are keeping track of packets which is lost or discarded in source only, sender only. Sender has all the packets in the buffer until some information has to come about this packets. If no information comes till timeout time, you have to retransmit it. We are maintaining this one. This also true, true statement. Recognizing the duplicate packet and discarding them. How we are recognizing the duplicate packets? Can you please tell me how we have to recognize the duplicate packets? How receiver is identifying these are the duplicate packets only. Respond. Isn't it by using what acknowledgement numbers or sequence numbers? Isn't it same sequence numbers comes with what? Duplicate packets only now. This also done. Buffering out of order packets until the missing packets arrives. So this also true because it is keeping in the buffer until missing packet comes. TCP accept, please, TCP accepting out of order packets but kept in a buffer until missing packets come. Once missing packet comes, entire buffer will push it to what? Upper layer. This also true. So therefore, A, B, C and D all are correct. All are correct. So I hope this is clear. Move on to next question. Now, in a stop and wait protocol, bandwidth of the channel is 1 megabits per second. 1 bit takes 30 milliseconds to make a round trip. If the system data packets are 500 bits in the length and the system can send up to 10 packets without waiting for acknowledgement. So simply window size given 10. What is the percentage of utilization of the link up to 2 decimal places? I hope you will solve it. Quickly solve. 2 minutes time. So 2 minutes time I am giving. 2 minutes I am giving. 2 minutes. Solve it. Solve this question. Very good, Vinay. Yes, try all of you. So bandwidth as given 1 mega bits per second is given, correct? 1 bit takes 30 millisecond to make a round trip time. Simply 2 times of propagation delay, round trip time given 30 millisecond given. If the system data packets are L size is what? Packet size is 500 bits given. 500 bits in its length, and the system can send up to 10 packets without any waiting for this one. Simply I can say sender window size is 10 is given now. So what is the percentage of utilization up to 3 decimal places they are asking now? Utilization now. So he is saying that capacity may be more, he is sending it 10 only sending. Window size is what 10 only sending now. So utilized by total, correct or not? Let it, you can take it in terms of time or in terms of data transmission also can do. Can I use what you can say bandwidth delay product? So bandwidth delay product. So what is the bandwidth delay product? Give what? Capacity of the channel will give, correct or not? Maximum data which we can send, capacity of a channel is nothing but 2 times of propagation delay into bandwidth I can take. This is a maximum capacity which you can send, right? This is a maximum capacity which you can send. Am I right? This is full time, full correct or not? Full value. Fully I am using this one. So this value is how much now? 2 times of propagation delay is this given 30 milliseconds, right? 30 into 10 power of minus 6 seconds into bandwidth is how much given? So 1 into 10 power of 6 bits per second, So second cancel. Now I can say 30,000, right? Capacity, maximum window size. So maximum capacity we can tell now. So maximum capacity which you can send it. So maximum capacity which you can send it what? 30,000 bits, correct? 30,000 bits. Isn't it now? 30,000 bits. Very good. Now efficiency is what? The efficiency we are sending how many packets? How many packets we are sending? 10 packets. Each packet size how much? 500 bits only. Out of what? This 30,000 bits only now. Into what? 100%. Isn't it efficiency? JP, Vinay, Hamad, 10 packets. Each packet size, one window you are sending now. Out of capacity, that's only, is it not? So like no, time spent for that by total time also. Total time is a round trip time plus transmission delay. Yes. So 16.66% is very good. Isn't it? Yes, everyone clear? So JP which you solve that manner, so by using the efficiency formula, correct? That is giving 16.37 something, correct? So range I should give it, right, because that is also correct, this also correct, isn't it JP? So range has to provide, I should give some 37 to something like this. Can be given like this, 16.37 to 16.67. It is make sense. Correct. So come to the point. Now in TCP connection between two hosts, host B receive the segment from host A, with acknowledgement number 6537. So now tell me what are the statements are right. What are the statements are right? Take it 3 minutes of time, observe and tell me the answer. Yes, what are the statements are right? So for 1, 2, 3 host JP, are you sure? 100% sure? Haruma saying that ABC. So 1, 2, 3. You are saying 1, 2, 3. 1, 2 only, not C. What about JP? Still 15 seconds are there. You can try. This has potential to make 2 mark question. So B and C. So means you are telling Vinay, out of order packets received the तो wrong हो सकता है options. No. I'm taking scenario like this. Okay, host A and B like this are there. So host B received the segment from host A with acknowledgement number 6534. Host B receiving the segment in which ACK number mentioned, right? Host B received the segment from host A with acknowledgement number is 6534. 6534 as mentioned. Okay. So this came. What is this will tell? ACK number tells next if you want to sending, we are expecting the data from what? 6534, correct? 6534, right? 6534. We are expecting the data from 6534. Nothing but this has a sequence number will send 6534 only, correct or not? Now my question to all of you, whenever acknowledgement something comes, nothing but it has some data, correct? Okay. Acknowledgement number, okay, acknowledgement number yes sent, right? ACK. Now I have received this one, right? I have received last byte. So isn't it this has received as 6533. This is the last byte sequence number which is sent by B, and receiver received is this one only. Can I understand? Can I tell now the segment which received by A from B, in which last byte has a sequence number 6533? We don't know about which is started, but this I can tell. Can we tell like this one? Hello everyone, you just answer this one. Can I say A, B, C, this packet segment A received the packet from B 6533, so that I am acknowledgement saying that I need expecting from 6534. So 6534 onwards he will send a data. So this we understand. Now by looking at this one, okay, his last byte is there. Can we say always, answer my question, can we say always 026533 data successfully received by A? Can we definitely say? Can I say always 026533 successfully received by A from the B? So now what if my starting byte is 6500? This also makes sense now. So starting sequence number may be 6500, it has sent from 6500 to 6533 successfully received. This is also possible. This also possible. Hello. It might have started, right? Might have started with 0 also, might have started with 100 also, might have started 1000 also, might have started from here also. Now read here. Host A received from 0 to 6533 bytes successfully. Can you say always this one? So by reading that number, host A received from 0 to 6533 bytes successfully. Can you tell this statement? Okay, come to the point now. Host A received all the bytes from the beginning. Beginning may be anything. Beginning means I cannot tell what 0. Beginning up to 6533 successfully. So now what is this? Must be true is telling now. Statement you see now. Listen, given the below scenarios, which of the following statement must be true? Must be true, always true, should be true. You have to be careful, right? So among this statement must be true is which one? Are they true? Both true or one of them true? JP, Hamad, Vinay, carefully read the statement and answer it. Can we say this is a must be true? Statement 1 is a must be true. It is may or may not always. So therefore what? Statement 2 is always true or not? So beginning, did I say beginning is 0? Beginning is, that's what a case I have taken. Na? This may be started with 6500 also, we do not know. You have to read carefully. Every wording is very important things. Many students make a mistake. Very good, Vinay. You exactly answered it. Very good, Vinay. BC. So host A expect the next data byte from 6534 from B. Correct? From this only will expect. Host A expects the next data byte. You read it. Host A expects. Now you can see host A expect the 6534 onwards only, right? Yes, this is true. This is also true. Host B expect the next data byte from 6534 from A. Host B expect that from that. No, can we tell like this? No. This is acknowledgement if we are sending nothing but B has to send from this one, correct or not? So this again, this is wrong, correct or not? If this is true, this is going to be wrong. Very good. So do silly mistakes during practice only. So don't do in a main exam, all of you. That's what, have a patience, focus while reading a question, because if you missed out something, we missed out. So I told you case number what? What is the case number? You understood also question, you know everything. Case number, what case number 2 I told you now? Case number 2 only. We are not reading the problem properly. Given information not read properly. So this can also make mistakes. So I hope this is clear. So move on. Application program communication interact with another application program. The prime requirement of the program is it want to send a chunks of the data to the application program at the other site, want to receive an immediate response required. Delayed delivery of the data may not be acceptable by the application program. So when you send us chunks of data, immediately I want a response, compulsory should deliver it. In this scenario, how TCP can handle this situation? So better you take the screenshot of it, so that I will show options. So very nice question, I can tell, very nice question, because it's purely conceptual. It is some fields we have in a TCP, so that will talk about this. Some fields in a TCP header that will talk about this one. Noted, noted all of you? Everyone. Chalo, now how TCP can handle? TCP is a byte oriented protocol. Every byte will be received in order, which may result in delay. Okay. Application program at the sender can request push operation, and sending TCP sets a push flag equal to 1, so that it can send it. TCP cannot handle the situation. So TCP can handle the situation, but the reason is not listed above. So what is the suitable statement I can do it? Yes, think and answer. Again, before making confirmation, review the question one more time, understand. Yes, all of you. So as we know, application layer, okay, now transport layer, application layer, whatever size comes, we are making segments, right? Segments you are making, correct or not? If suppose importantly, like, without waiting of making segment and lesser size of the segment, if you want to send it. So now this transport layer, what pushing, like pushing to what network layer. So network layer, right, by making what push flag equal to, right, push flag equal to 1, correct or not? So when I make it push flag equal to 1, what happens? When we make push flag equal to 1, what does means? So without waiting of making a segment, will push it or not? Will push it or not? So that it will be delivered. So wherever push block you see nothing but in network layer, what happens? In a network layer, how we understand priority bit makes into what? High, correct or not? So this all segments are pushed fastly to what? What's a receiver? So from the receiver, because TCP, this is TCP reliable protocol will get what responses. So can I do it or not? Can I implement with a push flag? JP, Vinay, Hamad, can we implement this application through what push flag or not? Making push equal to 1, isn't it? Come to the point. TCP byte oriented protocol, this part true, every byte will be received in order, that is true, which may result in delay. If you are using a push flag, it is not delay. If you are not using the push flag, it is delay. If it is not using push flag, it will be delay, it will go one by one. So application program at the sender can request push operation and sender TCP set flag equal to 1. True, this is true. This is true. So TCP cannot handle, this is wrong. TCP can handle the situation, but the reason is not listed. So does not require to list the information, right? Just make it what push equal to 1. This is also not suitable. I can do it with this one, correct or not? I can do with this what? Yes. Yes, Ahmad, correct. So that's what like you should notice about how push flag is used. That's what I told you, it's part of the one of the flag. Come to the point. Next. Answer it. Very important question. This is very important question, ma. So I am giving 2 minutes time. So I am expecting you should not guess anything. Don't do mistakes. Apply your knowledge. Tell me out of 6 statements, what are the statements are true? Which of the following is are possible in TCP? Don't guess it, make yourself 100% correct. Out of all statement, you can expect one more question is possible. In this area. But in a gate, this much information won't be there. Maybe 1 or 2, 3, 4 statement given. Try, all of you, try. Sir, 136 true, 1345 true. JP telling, how much saying 136. Okay, let's understand. In TCP, one can stop sending data while still receiving data from other side. So one side closed means other side can be received it. Correct? So this is true. I am marking true. The client off close connection by sending a FIN segment. So client has sent FIN segment, server accept it and sending acknowledgement. Server also send acknowledgement. Now the server can no longer, so let me take this connection. Okay. So client and server is there. Okay, already connection established. I am taking scenario. So now off close connection by sender, send client. Client has sent FIN. Okay. Only ACK came, ACK equal to 1 came. Okay. Now, so sending ACK, now the server can no longer send a data. Server can send a data or not? Server can send a data? Can able to send a data here, data part? Yes, he can send it. He can send it, right? He can send it, but client cannot be sent. Very good observation. So therefore, the statement 2 is wrong. Statement 2 is wrong. This is true. Next, 3. SYN segment contain the first sequence number which is randomly chosen. Yes. SYN segment contain the first sequence number used by SYN segment only, right? First sequence number. True. First SYN segment does not contain the acknowledgement. This is also true. So now when SYN segment you are sending, do you have acknowledgement number? Acknowledgement comes after sending something, correct or not? First segment SYN, first I am sending SYN, do I have acknowledgement here? I don't have this acknowledgement. First segment does not contain acknowledgement number. True. SYN segment defines the window size. Will it define the window size? When you are sending a SYN packet, does it define the segment size? What is the window has? So now see, please understand, when I say acknowledgement as number is there, by looking at acknowledgement number, by looking at a first sequence number, I can see my window size. Acknowledgement, through acknowledgement number, if you have next expected data, how much data I received, I can get it. Very good, very good. So SYN segment does not define the window size. This is false. False. Now what is the sixth one, true or false? Tell me. SYN ACK, SYN plus ACK segment consumes one sequence number if does not carry data. Are they consume the sequence number? Statement 6 is true or false? Just all of you talk about statement number 6. Is it true or false? Read, apply your knowledge and tell me. Everyone. Statement number 6, is it true? Very good. So this will consume, please understand, and this also will consume, but this will not consume it. So therefore this is false. This is false. So true statements are 134. 134. Am I right? 134. How many people answered? Anybody got 134 answer? Very good, very good. Move on to the point. Now can you answer? Sequence number used by the first byte is 100. What is the sequence number used by the last byte? Last byte sequence number. Can you answer? Sir, in a SYN segment contain the information sender as maximum segment size. Maximum segment size has, but window size we have. They are talking about window size, na? So generally window size I can get it from what? Advertised window, correct? Can we get window size also here? So just I am going back, so just a minute. For SYN segment defines a window size. SYN segment, when I send it synchronization, can we define the, okay. So can I get it, okay, maximum segment size is there. Maximum segment size we have. Maximum segment size we have. SYN packet we send one maximum segment size. Window capacity also will send it. So just a minute, but just I am reviewing this one. So client and server, if you take, what are the information we are sending? We are using some sequence number, maximum segment size. We are also my window size, how much I am sending, correct or not? We'll get his own sequence number. He will give it ACK number equal to 1. ACK number will be there. Then is comma maximum segment size we have. So window size also we have, correct? Okay, we can have, we can get it to know this one, correct or not? We can get it to know, right? Alternate MSR defines the window size. Of course, that is there. Yes. Just removing this one. Okay. So defines the window size. This is also true. Therefore, I can add it even fifth statement also correct. Very good observation, JP. Okay. Now come to this question. Try it out. So total what you can say IP datagram header is there. This entire thing is what IP packet. Size has 620 bytes is there. Now sequence number used by this first byte is 100. What is the sequence number used by the last byte? Can you please answer this question? Yes, all of you try this question. So we are at network layer. Okay. So network layer, this total size is what 620 bytes, correct? 620 bytes, in which 20 byte header will be there. This is a 600 payload we have, correct? 600 payload will be there now. So this will come from what? Transport layer, correct or not? Transport layer it will come. Now transport layer header also 20 bytes is there, right? 20 bytes is there. So 20 bytes is there, correct? 20 bytes if I remove it, so 580 will be there, right? 580, right? 580. Now anybody answer 670. So very good. If you apply the formula, otherwise you understand. So now here first byte is used as 100. Last byte 500 plus 580 minus 1, correct or not? 680 minus 1 equal to 679. Very good. This having 679. Can be answered? Yes, very good. Ma. So answer is 679 is the answer. Yes, we'll move on. Easy. This easy. Now, can we answer this one? Just recall the state transition diagram. JP correct. Even Hamad also correct. I hope Vinay also clear. Now just check this question and what is the state? The state, does the client TCP wait for ACK for FIN? check all of you properly, observe 3 cases of termination process we have seen. Termination of phase, three are there. 3 cases can be seen. 3 cases can be seen. Three cases can be seen. So what is the situation as is mentioned? Client has sent FIN request, server also send a FIN request. Client has received a FIN and send acknowledgement. He already sent a FIN, he already sent a acknowledgement also. Who's client? Then which state he will move? Which state client will move? So in which state does the client TCP wait for ACK for FIN? He got a FIN, so he has first sent a FIN request, server also sent a FIN request, client has received the FIN request, he sent acknowledgement waiting for something, simultaneous closing, very good. Situation is what? Simultaneous closing, correct or not? Okay, just a minute. So I'll be showing you, okay, TCP process state transition diagram. TCP state transition diagram if I take, okay, let me take this part. I hope it is visible. Is it visible, all of you? Is it visible, everyone? Just taking the scenario. Okay. Now this is a client, this is server. Client sent a FIN request. Can you see FIN request? After sending FIN request, he will be here, correct or not? Then he won't also close it. He also send the FIN request. Server also send a FIN request. So can you see now here case? Can you see now here case number 1? Is now see FIN sent waiting for 1. Now see here this is the line I am writing, FIN by ACK. What is the meaning FIN by ACK? Downside we will talk about always sent and received. FIN received, sent ACK, moving to which state now? Is it clear? Client send a FIN request, downside is always numerator, denominator talks about sent. It is received, correct? Received thing it will talk, correct or not? He has sent, waiting at FIN wait 1, but server also sent FIN, right? That's what you know, FIN received, ACK sent. Client FIN received, ACK sent, moving to what? Closing. Then waiting for what? Acknowledgement from the server. So when acknowledgement receives, wait for time wait and then will terminate. Over. Isn't it easy? The simultaneous closing cases. So I'll just moving this one back. Okay, come to the point. So straightforward we can answer this question, right? Closing. This type of question highly possible. JP and Vinay Hamad properly observe the process state transition diagram about TCP. Theoretical question, 2 mark question is possible in this area. In this area possible. Moving on. Now, so now what is the value of x plus y plus p plus q plus r? Can you please answer? I hope it is visible. Is it visible, all of you? Everyone. The values are visible. If you want, I can, what I can do it, I will select, okay. Is this visible, all of you? Yeah. It is a client and server. He sent a FIN request. Okay, he sent a FIN request. Understand? FIN request. In a sequence number 5000 is there, ACK number 2000 given. Now from this ACK packet came sequence number X, ACK Y. Then the data transmission from server to client and acknowledgement from client to server is there now. After that he also sent fin segment. Sir, the banner below is blocking it. Oh, okay. Let me rewrite better. Okay. So let me rewrite. This is scenario. Okay. Fin request. Yes, send a fin request. Sequence number 5000. ACK number 2000 used. Client and server. Okay. After this ACK packet came, sequence number used X, it is X, ACK number used Y. Okay. This is a fin request. Fin request, correct? Fin request. After some time, he send a fin request. Fin in which sequence number 8500. ACK is P. ACK P. There is a fin request sent. Now ACK came back. ACK packet came. ACK is R. Sequence number is Q. Now X plus Y plus P plus Q plus R value they are asking. X, Y, P, Q, R. X, Y, P, Q, R. Can you please answer now? Quickly, can you please answer everyone? Tell me what is the X value, you can tell me what is the X value, what is the Y value, what is the P value, what is the Q value, what is the R value. As per your knowledge, these types of questions also highly possible. Yes, all of you. Try this question. Vinay, carefully check. You have studied in the class, correct or not? This is connection establishment things only, right? Connection establishment, data transmission phase, termination phases, right? This is especially termination phase only, right? Fin request. Client want to close first, then after that server is closing. X equal to 5001, Y equal to 2001. X equal to 8500, Y equal to 501. Here after that some data transmissions over here, please understand. This data transmissions over, after this only it is establishing. this is active close, this is a passive close. Some data, because data can send, server can send the data. See what is ACK? If client sending ACK number 2000 means what? Till 99 and 99 I received it. I am expecting the data from what? 2000 onwards. Now E is going to use the sequence number to this one, or isn't it? Now X value is 2000. Confirm me, am I right? Hello, JP, Hamad. Is the X value is 2000 or not? Or in 1999? Which one is? Sequence number I use, his own sequence number you will use. Acknowledgement always with respect to what? Acknowledgement 2000 he is sending 2000 means what? I am giving acknowledgement nothing but I am expecting the data from next. I am expecting the data from next, correct or not? Now Y is what? What is the Y? So he has sent X, as what is the 2000? Okay, I am sending onwards. I am giving acknowledgement nothing but what is giving acknowledgement? Fin request already 5000 consumed nothing but Y must be what? 501. Y must be 501. Very good, very good. P, what is the P now? Sequence number 850, what is the P value used? Acknowledging to that. ACK, I am client, I am expecting next. Fin already consumed 5000. P also should be what? 501 only. P also 501, because see, acknowledgement always tells I am expecting from next onwards. Sequence number you used, last sequence number used by client is 5000 only, correct or not? This is 850 used by server, not by the client. 5000 already used, nothing but 501 only. Q, what is the Q? So what is the Q says now? Q says next time explain. ACK using R. So now see, ACK, this acknowledgement says that next expecting. So 850 fin consumed nothing but can I say 8501. R is what? R is what? 8501? 8501, not 02. See ma sequence number used. I am acknowledging to this one. Fin 8501 consumed. 8501 only. What is R value? What is R value now? R value. R value I am expecting from server. R value must be Q value 500. So Q value also 5001. So let me check the Q value. Q is the sequence number used by this I can use 501 only because sending this 501 only. So R must be acknowledgement to that nothing but 8501. Correct. R is 8501, Q is very good because so sequence number used by this one, correct or not? Last used 5000, next is 5001 and I will use it. So I hope this is clear. Now tell me what is the value total? Total value. Very good observation. Yes, what is the value? What is the value? Two 5504. Correct. Very good. Move on to next. Consider additive increase multiplicative decrease algorithm. Okay. At the start of the slow start phase, conjunction window size is 2 MSS. At the start threshold is 8 ms. So assume 3 duplicate acknowledgement is received during 5th transmission. Find the conjunction window end of the 8th successful transmission. Successful transmission nothing but ACK received, correct? Successful transmission means what? ACK has received it. Tell me now, what is the answer? What is the answer for this question? So what is the question? Find the conjunction window end of the 8th successful transmission. It started with the slow start phase, conjunction window 2 ms, 2 maximum segments I am sending. After successful transmission nothing but round trip time, it is doubling, right? 4 MSS. Threshold value is what? 8 ms. So 8 ms I am sending, 8 ms. So now threshold reaches means what? Next is what? So now this is a threshold we reached it, correct or not? This is a slow start phase, exponential growth, then after the linear growth only, correct? A linear growth only. So we have to send 9 MSS increase. So now what they said, 3 duplicate acknowledgement is received during the 5th transmission. 1, 2, this is the first transmission, second transmission, third transmission, fourth transmission. This is the 5th transmission, we have sent 10 MSS. So 10 MS I send, 10 MS I send. Then what happened now? So some packet is lost, 3 duplicate ACKs came, 3 ACKs came, that is lost. Then therefore what I have to do next onwards? Have to start what you can say? When 3 duplicate ACKs received it, we have to start linear, right? Linear growth. Conjunction avoidance phase you have to start. Threshold value will be half of this value. 5 MSS you have to make it threshold value. Then send linearly, linear nothing but 5 you have to send it, 5. Unsuccessful receiver 6 MSS. Unsuccessful receiving 7 MSS, 7 MSS. Now see, 1, 2, 3, 4, 5, this is 6th transmission, 7th transmission, 8th is successful transmitted nothing but, so next window size is what? 8 MSS. So this is answer, answer is what? 8 MSS is answer. So successful transmission means ACK received, very good. Sir, go with the conjunction, very good JP, Vinay also correct, JP also correct, very good. So move on to other question, now. Consider the instance of TCP additive increase, multiplicative decrease algorithm. Window size at the start of the slow phase is 1 MSS and threshold at the start of the first transmission 16 MSS. Assume that timeout occur during 9th transmission. What is the conjunction window size in MSS after 15th round trip times? What is the conjunction window size in MSS after 15th round trip time? I hope you can able to do it, take it for homework, okay? Work out, take the screenshot of it. It is same only, right? So Vinay is 7, please, that's a doubt, generally will make a mistake, Suppose if I say during 8th transmission means my window size is 7. PYQ same question we took answers as, no, that is a 2 questions can be answered. If suppose, find the conjunction window size end of the 8th successful transmission. The word is what? Successful transmission is what? When I say successfully transmitted, simply 8th transmission if I use word, when I hear right only, I understand your doubt, During 8th transmission or end of the 8th transmission, I transferred, my job is done. That moment my window size still 7 only will be there. When I use the word successful transmission means what? What this successful transmission defines? In that PYQ successful it is not their word. At the end of the 8th successful means for starting of the 9th one. Very good, very good. If during 8th given is that, we take 7 only. Very good observation. Does Vinay, this was there, successful transmission, successful word was there? Sir, if you during the 8th given, then we take 7. True. Vinay, just I am confirming the word was there, like, so find the conjunction window size, end of the 8th successful transmission, word was there? It was end of the 10th transmission, right? 10th transmission. 10th transmission means a transmission is over. I transfer, no, example, end of the 7th transmission, 8th transmission, if I say, 8th transmission 7 ms, I send it. Transmission over. Transmission, transferred over. But the word successfully, we use the word. I know that question. We have, I think, successful word is not there. Sir, yes, that in that question was asked in 2012. Successful was not there word. Word successful was not there. When I say successful means what? We received acknowledgement. Acknowledgement received nothing but window is slided, right? Window is shifted. Window incremented. The wording is very much important now. Or else you can say after some round trips, they can also other way, direction is what? Example, round trip 1, round trip 2, round trip 3, 4, 5, 6, 7. After 7 round trips, what is the window size means? So we can tell after 7, this is what? Suppose 1, 2, 3, 4, 5, 6, 7 over. So now my window size 7 only, right? After 7 round trips, my window size still was same on 7 ms. After 8 round trip, nothing but my window size becomes 8 ms. So be careful with the what you can say wordings. Vinay, how it is clear? You can verify that one. Yes, 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 yes. Yes, yes, I've seen that question. The word was not there, successful word was not there. So I hope this is clear. So this you can try, it is easy. This you can try now. So come to the point. The following content of UDP in hexadecimal format given. What is the destination port number in decimal? Can you be answer? Can you answer, all of you? The following content of UDP header in hexadecimal format given. What is the destination port number in decimal? So destination port number in decimal. Destination port number decimal. So now please understand, UDP header size is fixed 8 bytes. 8 bytes nothing but like this will be there, right? This is a 4 byte size, another is 4 byte. We have a source port number, destination port number, 2 byte long, this is 2 byte long. The followed by header checksum, simply checksum and total length will be there, length will be there. So 2 byte nothing but I have to read it 2 byte like for 1 byte equal to 4 hexadecimal. 1 byte has 2 hexadecimal, right? This is gone. So now you have to read this value, right? This value. So 000A. This A nothing but 1010. So in binary to decimal make 10. Okay, answer is 10 now. Very good, very good, very good, Ma'am. Very good. So quickly move on to this one. Which of the following, which of the services below uses UDP as a transport layer protocol? UDP using services. DNS uses, yes. BootP also uses, yes. DHCP also uses. This also uses, right? Network time transfer protocol, network protocol. So now zone time translations. So suppose very simple, like no, I want to know what out the destination timer, like destination time, what is current time now, like this. So all uses, because a request and reply form is there. Wherever request and reply form is there, so we have to use UDP services only. All are correct. All are correct. All are correct. Now, can you check this one about DNS? DNS. So DNS. Can you answer this question, man? The host name to the client So now just take this one, mapping is required now. Which of the following correct sequence to map host name to IP address I need to find out. Take first screenshot, take the screenshot. Take the screenshot of it. Have you noted this one? Yes, all of you. So last question, Vinay, we are going to stop the session. Which of the following is the correct sequence map to host name to IP address? Because DNS majorly mapping from what? So domain name to what? IP address. And we can do vice versa also. What is the first step we have to do it? What is the first step we have to do it? Carefully read. We know how like the framework of the DNS server, DNS DNS server, not DNS server. I am just saying that what is the framework of the getting the IP address from given a nome, given domain name. So when I type it www.google.com, for this I need IP address. So what are the framework, what are the steps involved to get the IP address from DNS server? Among this, which step has to do first? Host name to the client DNS is possible file transfer. What is the first step I have to do it? So 516243 you are telling 516243, 516243, 5164. So 51 you are saying 516243. So 5 is what? To the file transfer client, user passes a host name you have to do, correct? This is the first I have to do 5. So host name you have to send it. After that, host name to the client DNS passed by the file transfer client only 51. Then okay. Then after 51, which one is the server respond? No, a message is sent to DNS, message sent to server DNS by the client with a query that given the file transfer server name will be there, knowing IP address of the DNS server also will be there. Very good, this have to take it 6. Then the server DNS respond IP address desired file transfer, correct. IP address passed to file transfer client by the server DNS, correct. 3 is what? IP address I can use it, right. Very good. 516243, 516243, correct. Option B is right, ma. Option B is right. So one more question we have to see. Question related to network address translation. Network address translation. Consider the following statement. Which of the above statements are correct? Network address translation allow a site to use a set of private IP addresses for internal communication and set of global internet addresses, at least one for communication with the other network in the internet. Network address translation router replace the source address in the packet with a global network address translation. Yes, tell me what are the statements are correct? These two are correct or not? Yes, tell me ma, what are the statements are correct? There's two statements, tell me both are right or both are wrong or one of them true, one of them false. Yes ma, those who are watching, check the statements. So sometime they can also frame a question. I think one of the year, I think last year or 2024 only, there was one more question related to network address translation, one of the session. So generally, you know applications, right? Like router, this router will translate. This is a public IP. Public IP is that this is my local communication. I can use a private addresses to communicate local. So whenever one of the hosts want to participate in internet, whenever hosts want to participate in internet, I need public IP. Correct or not? So then this IP address will not send it. It will take one IP address of the public IP. So that public IP acting like a source IP address of this one. Correct or not? So let me clearly, if you see, clearly if you observe it, what I am trying to say, this is a private network, maybe host are there, n number of host assumption. Now here is a router, okay, router is there. Now these are the public IP, okay, public IP is a public internet is like this, understand now. So this is a host 1 assumption, host 2, host 3, okay, sending a data packet, maybe using this data packet, maybe somewhere one is there, okay, public IP is there, let's take so 160.160.0.1 is there something, okay. Now this has a source IP address, let's take it is maybe using 192.168.1.1. This is a private IP or not? Private IP. Source IP address it is used and the destination IP is what? What is the destination IP? So 160.160.0.1, correct? This packet has came now. And nobody will understand this IP address in public. Please understand. Are you getting my point? Nobody will understand this private IP here, public, correct or not? What this has do, it has some mapping table, please understand. In this mapping table, it will maintain a private IP address 192, so dot 168.0.1.1. For this one, port number will create, let's take port number something 2000 assumption now, 2000 assumption now. So this will create a packet, please observe. Source IP address means it won't use this one. It will use its public IP. One public IP it uses public IP. Let's take example. Maybe 100 dot. Let's take 100.1.1 assumption as a source IP address. Destination is what 160.160.0.1 and followed by port number. Source port number has 2000 uses like this. So 2000 you send it now. Now see source IP address replaced by public IP, ma. Source IP replace public IP. Replace public IP and sent. Now whenever response comes, so response comes, this is a destination IP, it is a source, correct or not? When it is comes, you know how exactly router will identify among the sources. Many source will be there in the client, in the local communication, right? How router is going to identify? I have to deliver it here only. That's why reason it is maintain the port number now. So now when a response comes from this public any system, port number 2000 comes. It will search a port number here, corresponding whatever IP is there, IP will be replaced and sent to this one. So that's how network address translation work at router. It is one of the mechanism of the router translating of addresses, private to public, public to private. Now with this record, tell me, read the statement, tell me now. Yes, yes. So JP, what is your answer? Other people think and answer it. So both are correct or not? Because see, it translate the set of private IP address will be there. At least one global IP address should be there. So with this we can able to translate or not? Yes, this also true, this also true, correct or not? It is a source IP address in the packet, no? A router replaces source address in the packet with a global network address, correct or not? Replacing or not? Just now we observe replacing and sending, correct or not? Yes, both the statements are right only. Both the statement are right, ma. Okay. So now with this one I am trying to say like most of the concepts we covered from first session as well as second session, ma. So what is the conclusion from IP like application protocols? Try to focus on HTTP, SMTP theoretical aspect, port number, their functionality, their features like SMTP, FTP, like POP3, IMAP, MIME protocol is there now. So even FTP you discussed. These are the things try to focus more on. You are able to solve it. Okay. First session also we covered many things, correct or not? Thank you, JP. And also like which is planned tomorrow, that is 29th December, C in data set algorithm also planned that you can work out. And also we'll try to take even compiler design other subjects also in upcoming week, we'll plan it, ma. Okay. So I hope this session definitely might help you for you. And those who are not able to join live, later also you can watch and utilize the revision, quick revision through problem solving, because many concepts we discuss properly. Any doubts are there, all of you? Anybody having any doubts? Anybody having any doubts? So you can join this the Telegram group, ma, because you can get this PDFs and other things also. Okay. So shall we close the session if no more doubts are there? Thank you, ma. Thank you so much. Okay, ma. Okay. Okay, ma. I'll be stopping the session. Thank you all. Thank you so much. So most welcome, ma. Most welcome, all of you. So what I am just suggesting everyone, whatever you felt it, all of you, you can comment on the video so that this will help for other aspirants to watch this video, correct or not? If you recommend it, like no, so many people can watch, they can utilize the importance of this session, everyone.